Hi everybody, this video is going to talk about lesson 6.2, which is multiplying and dividing rational expressions. So first of all, what a rational expression is a quotient of two polynomial expressions. It's just a fraction, that's all. Anytime we see a fraction, that is a rational expression. Another thing that we talk about a lot in this unit is what can simplify. And I will tell you, these two, they cannot be simplified. Some people think you can multiply or cancel out that 10 and 6 and reduce it down to 5 and 3. Nope, you cannot do that. Some people think you can cancel out these x's. No, you cannot do that. Now this one actually can be simplified, and the reason it can be simplified is we can factor it. And when you simplify, what you're really doing is canceling out factors. And so if there are factors that you can cancel, then yes. But just adding and subtracting, no, you can't do that. So this one actually does simplify to just x minus 2. But we're going to spend most of our time talking about that, so I'm not going to go into that huge right now. But rational expressions can be simplified like fractions by dividing out common factors from the numerator and the denominator. So you have to be able to factor it. If you cannot factor it, you cannot simplify it. And by factors, I mean what you multiply. So anything that's multiplied, that can be canceled. Anything that's added and subtracted, nope, not unless you can actually factor it. Okay, so for instance, there is a greatest common factor between 16 and 8. What's that greatest common factor? Well, it's 8. So I can factor out an 8, and I can factor out an 8, and I get this 2 over 1. The x's also have a GCF of x squared. So I can factor out x squared, and I factor out x squared, and when I factor out x squared over here, I get x to the 9th. So my final answer here would be 2x to the 9th. The thing is, they have to be factored. Now, we're also going to talk about domain, and the domain is another important part of this unit. The domain is we have to look at the denominator because remember, you cannot divide by 0. And since you cannot divide by 0, then the domain has to do with when is the denominator 0. So let me show you a couple of things in the margin. When we talk about domain, we're basically asking about where the expression is defined or it does exist. And so a lot of times what we talk about is we say all real numbers except, and then we list the ones that don't work. And the all real numbers, it's a capital R. It's actually like a kind of like a paragraph R that has like 2 lines on it. That means all real numbers. Once again, do not cancel with adding and subtracting. You have to factor it first. Okay, let's take a look. Does anything cancel out? I'm not sure. So first of all, let me tell you, do not cancel this 3x and this 3x. That does not work that way. That's not how things cancel. The way things cancel is we factor them. So I'm going to look at this denominator and I'm going to see, can it be factored? What I really want to know is not only can it be factored, but can it cancel with this? So in other words, maybe try that 3x plus 4 to see if it can cancel. And if that's 3x plus 4, this must be x minus 1. Because that's the only way that would work. So that would be 3x squared minus 3x. Oh, this will. So this was a guess and check. I guessed. Let me check it. When I check it, I get this. These do combine to be a 1x, which is what I have here. So yes, this does factor to 3x plus 4 and x minus 1. What that means is that can cancel out because they are a common factor. And remember, when you cancel things out, don't forget to leave as 1 up there. You can't just leave nothing. It's not, the answer is not x minus 1. The answer is 1 over x minus 1. We're going to do one more example and then we're going to talk about domain. So in this example, once again, we're going to have to see if it can be factored. So this is a tougher one. You might want to do this with the splitting the middle term. So I actually did the numerator with guess and check. But see if you can factor the denominator, and when you do, see if any of the factors will cancel with the factors in the numerator. Okay, so I got the denominator to factor as well, and notice I have a common factor, so I can cancel out that common factor, and so my final answer is just 2x plus 1 over 2x minus 3. I'm going to try to fit that in here. Okay, let's talk about domain. The domain, like I said, it's any time that the denominator isn't 0. And I'm going to have to erase so that we can see what's going on here. So let me erase this. This was 8x squared. How could we possibly make that 0? Well, what we're going to do is we're going to say, when does 8x squared equal 0? So if we divide by 8, we get x squared equals 0. We take the square root, we get x equals 0. So the answer is all real numbers except 0. Let me explain that a little bit more. So the domain is all real numbers except 0. In other words, if I plugged in a 1, this fraction would be fine. If I plugged in a -5, the fraction would be okay. If I plugged in a 0, though, that's not going to work, right? Because we have a 0 in the denominator. We can't divide by 0. That makes it non-functioning. It doesn't work. So that's how we're going to look at what is the domain. On this one, again, I'm going to erase this in just a second, but on this one, what I'm going to do is I'm going to take advantage of the fact that I've already factored it. And so the fact that I've already factored it, I can set each factor equal to 0. And when I do that, obviously this is x is 1. And when I do it over here, I subtract 4. And I divide by 3. And so here, my domain is all real numbers except these two, -4/3 and 1. In other words, if I plugged in a 1, I would get a 0 in the denominator. That can't be. If I plug in a -4/3, I would get a 0 in the denominator. Not supposed to have a 0 in the denominator, so anything else would work though. A -1 would work, a 10 would work, a 35 would work, whatever. But -4/3 and 1, they do not work. Even a 0 would work. Look, if I plugged in 0, what would I get? I'd get -4. That's okay. You can have a -4 in the denominator, but you can't have a 0. And so all real numbers except -4/3 and 1. Same thing here. I'm going to set 3x plus 2 equal to 0, and I'm going to set 2x minus 3 equal to 0, and I'm going to solve those, and I get -2/3 and a +3/2. So that means that my domain is all real numbers except these two, -2/3 and 3/2. Because I plug those in, I'm going to get a 0 in the denominator. I don't think we need to go through every single problem. I do want to continue to talk about domain because that's something that's new to us. Think about this one. It's going to be all real numbers except what? Except 0. If I plugged in 0, it can't happen. If I plugged in, how about this one? Well, I would have to factor it first. Let's take a second to factor it. So I factor it, I get x plus 3 and x minus 1. That means all real numbers except -3 and +1. Anything else is okay. Okay, this next section, it deals with negative numbers. And so let me just dive in and start to take a look at this. You'll notice that the bottom here, the denominator here, is already factored. Like we can't do anything with that. We need to look at the top. How can we factor the top? And when we factor the top, it's kind of out of order. See what I mean? So I might want to write it in the correct order first. And then I'm going to factor out a -2. Okay, look what happened. Now I have x minus 5 and x minus 5. So this one I already factored out. I don't need to pay attention to that. Here I have an x minus 5. Here I have an x minus 5. The answer here is -2. The domain would be all real numbers except 5, because 5 would make that denominator 0. Let's take a look at another one. Let's keep going. Example B. What can we factor out? Well, I see a GCF of -x, and then we have x plus, now x minus 3. In the denominator, we need to factor this. And we're going to see if anything cancels with what's in the numerator. So in other words, I'm going to take a little shortcut and say, well, I already have an x minus 3 here, so maybe this is supposed to be -3. If that's a -3, this must be a -1. Let's do a guess and check. Here's the check. 2x squared minus 6x minus 1x, that is minus 7x plus 3. I'm good to go. Now, I want to cancel these. My x minus 3's cancel out. And then on the numerator, what I have is a -x, and the denominator, I have a 2x minus 1. I'm done with that problem. The last thing I need to say is what is the domain? And the domain is all real numbers except it's going to be a +1/2 and a +3. Okay, once again, letter C is kind of in the wrong order in the numerator. And that is basically what this is going to really boil down to, is having things out of order. So I'm going to rewrite it in the correct order. -x squared plus 4x. I'm going to factor out a -x. Why is it negative? Just because that you don't like to have a positive as your leading coefficient. I mean, you don't like to have a negative as your leading coefficient, so you factor out the negative so that it's gone. Now we're going to have x minus 4 here. Now I want to factor the denominator. Looks like a -4 and a +2. Then my -4, so this one I've already factored out. This one cancels, and so I'm left with a -x over x plus 2. What's my domain? My domain is all real numbers except 4 and -2. I have to say, none of these three examples really did what I wanted them to do. So let me give you an example of what I really want to get at. And that is, what if you have 7 minus x over x minus 7? That's what I really want to talk about. Well, my numerator, let's rearrange it. -x plus 7. And my denominator is still x minus 7. My numerator, let's say I factored out a -1. Okay, I factor out a -1, and now these two cancel out, and this comes down to 1. That's what I really wanted to get at in this, and I wish I had done better examples. But anytime you see those where they're like the same numbers but flipped like that, it actually reduces down to -1. So for instance, if I had 5 minus x over x minus 5, that reduces to -1. That's what I really wanted to get at. Let's flip the page. Okay, there are various ways that people do this. And when you get a lot of experience, then you can start deciding how you want to do it. But right now, I think the best way to go is to multiply straight across. And then after you've multiplied, then go ahead and factor and simplify. If you try to, I don't know, go like out of order, it just starts to get really messy. So let me show you what I mean. I'm going to multiply straight across. That's going to give me a 20x to the 8th over 30 x to the 5th. Now I can just simplify that. I know I can factor out a 10. So if I factor out a 10 out of here, I'm left with just 2 over 3. And I can factor out the x to the 5th out of here. And when I do that, I'm left with an x to the 3rd. So there is my final answer. The domain, all real numbers except 0. I said multiply straight across and then factor and simplify. So even though I said that, which I did, and I stick to it, don't multiply it, like don't distribute it just to then refactor it. That doesn't make any sense. So let me just keep this as 10x minus 40, forgot my 0, and x plus 3. And in the denominator, x squared minus 6x plus 8, and 5x plus 15. Okay, and you might say, why? Anyway, let's just go with it, okay? So now, if I factor out a 10 out of the top, I'm going to have 10 times x minus 4. This one does not factor, so I just have x plus 3. I'm going to cross these out to show that I've already factored them down. This one can also be factored. X minus 4 and x minus 2. So I've factored that one. This one I can factor out a 5, x plus 3. That's been factored. Okay, now I'm going to see what I can cancel. I have an x minus 4 and an x minus 4. I have an x plus 3 and an x plus 3. I have a 10 and a 5. Now my numerator, I've crossed out everything except for the 2. The denominator, I've crossed out everything except for the x minus 2. Oh, could I cancel that 2 and 2? No, don't cancel those. You cannot cancel with positives. You can't do it. You have to factor it out. This is being added, not factored, so not possible. Okay, my domain might be quite extensive on the domain, so I'm going to go ahead and talk about the domain here. The domain here is all real numbers except 4, 2, -3. Even though I've canceled them, I still have to put them in my domain. However, the 5, it's not an x equals 5, it's just plain old 5. Don't do that one. So here's my domain. I have a little note here. If everything cancels, don't forget the 1. That might come in handy. So let's go straight across. It's going to give me a 30 and x to the 8th and y to the 7th. Denominator is going to be 18, x to the 5th, y to the 12th. Okay, could I have canceled stuff inside there? Yeah, of course. But I'm going to simplify my life and go right across and then simplify later. So now factors. Factors of 30 and 18. I know 2 can go in there. In fact, 6 can go in there. 6 can go in there 5 times. 6 can go in there 3 times. Okay, x's. I can factor out an x to the 5th. X to the 5th goes away, makes this x to the 3rd. Y's. Y to the 7th can be canceled, gives this a y to the 5th, because 12 minus 5 is 7. All right, so now I have 5x to the 3rd over 3y to the 5th. Usually when we have both x's and y's, I'm not going to worry about domain. So don't worry about domain here. It just gets too complicated. Okay, next one. Again, I'm going to multiply them, but just put them next to each other. I'm not going to distribute them. And same thing here. Numerators can't do anything with them anyway. Denominator 4 comes out, x plus 5. And this is x plus 3, x minus 3. Okay, let's look for things that we can cancel. Common factors. Common factors, x plus 5, x plus 5, x minus 3, x minus 3. I feel it's like playing Go Fish. You get your pairs. All right, here's the deal. I've canceled everything in my numerator. When you cancel everything out, you have to put a 1. If you don't put that 1, you have an entirely wrong answer. Totally wrong. Upside down wrong. Okay, and then this is my denominator. As far as domain, I could see that my domain is all real numbers except 3, -3, and 5. Next part's division. The only new thing about division is we multiply by the reciprocal. It's not that new. Hopefully you've learned that before. So I'm going to change this to 12y squared over x to the 4th y. Some of you might have heard it as keep, change, flip. Is that right? Something like that. Yeah, keep, change it to a times, and flip this upside down. Okay, so now when I multiply straight across, I'm going to have 12x squared y squared. In the denominator, 4x to the 4th y. All right, I'm looking for common factors. 4 and 12 have a common factor of 3. X to the 2nd and x to the 4th have a common factor. I factor it out, and I'm left with a 2. Y and y squared factor out. I'm left with a y to the 1st. So now what I have is 3 over x squared, and looks like that's it. Oh, sorry, my y in the top, right? Y in the top. And I remember I said, oh, well, you know what? When we, I want to talk about denominator, I want to talk about domain, but let's actually do that with this one instead. I'm going to keep this, I'm going to multiply by the reciprocal. So I'm going to change it to times, and I'm going to flip it upside down, and I'm going to rewrite it. So I have 2x squared minus 7x minus 4 times 8x squared minus 28x plus 12 all over x squared minus 9 times 4x squared minus 1. I have a lot of factoring I need to do, and I don't have space to do it. I'm going to try to make some space. So in my numerator, I need to see if these factor. I'm guessing they do. Ooh, this one, you know what? Look, it has a factor, a GCF of 4. Let's take out that GCF of 4 to make our lives a little bit easier. This one I haven't done yet. I feel like we did this one just a minute ago, didn't we? Let's make this a minus 4. We didn't do this one. It was a little bit different. That's a minus 8 and a plus 1. That works. Down here, I have an x plus 3 and an x minus 3. And I have a 2x plus 1 and a 2x minus 1. How to do that one so fast? Because it's a perfect square. Perfect square minus perfect square. So was this one. Okay, what can we cancel so far? I haven't even factored this one yet because I wanted to see what I could get away with. We have a 2x plus 1 and a 2x plus 1. And that's it. Bummer. I need to factor some more. Okay, remember I had that 4, but now I've got this. So let's factor this down to 2x, x, minus 7. So how about minus 3 and minus 1? That should work. That's a minus 6 and minus 1. That works. Okay, so I have factored this. I still have my 4. Don't want to lose track of my 4. I have this one left over as well. I've gotten really messy here, but these are my numerator. These are my denominator. So things I can cancel. My x minus 3, x minus 3. 2x minus 1, 2x minus 1. Excellent. A lot of stuff is canceled out. What I'm left with in the numerator, I have a 4 and an x minus 4, and everything else is gone. 4 and x minus 4. In the denominator, all I have left is an x plus 3. Nothing left except for that. Okay, this is my final answer. I do need to talk about domain. In the domain, you have to list anything that was ever in the denominator. At any point in its life, was it in the denominator? Then it has to be listed. So, really running out of room here, but our domain is going to be all real numbers except positive and negative 3, because those were here in the denominator at one point. When I factored this, I actually factored it down here, and it factored out like this, and I'm just double checking. Yep, that's right. So that is a positive 1/2. Now I already have 3 listed, so I don't have to list it again. Now I want to go to my new denominator, and my new denominator also has positive negative 3, got that. It has a 1/2 and the other one, so we have to include both, positive and negative. So in your denominator, or excuse me, in your domain, you have to list out anything that was ever in the denominator at any point. Last question is solving equations. We will actually be doing a whole section on equations, but these are just equations that we can do really easily. And the reason we can do them so easily is because this numerator factors into x plus 4, x minus 3. And so now we can see that the x plus 4 cancels out. And so we get x minus 3 is equal to negative 7. So I get x equals negative 4. However, we have this thing called extraneous solutions. And the extraneous solutions are something that looks like a solution, like that sure looks like it worked, but we have to keep in mind the domain. What's the domain here? Domain here is all real numbers except negative 4. How come? Because if we plugged in a negative 4, we would get a 0 in the denominator, and that would not work. So this one actually is no solution. Okay, last problem. Okay, once again, we want to factor that numerator, 2x plus 3. It's a difference of squares, so I know how to factor that. And the 2x plus 3 goes down here. You set it equal to 5. Okay, the 2x plus 3 is canceled. So now I have 2x minus 3 is equal to 5. That's 2x equals 8. That's x equals 4. Okay, let's check the domain. Is 4 okay? Yes, 4 is okay. The domain would be all real numbers except negative 3/2. This one works, so this one's okay. All right, we will talk a lot about this in class tomorrow. Please bring your questions. Be prepared to discuss a summary. We're going to talk about some questions from this unit, or this section. So write some things down in your summary and be prepared to talk about that when we come back to class.